So in this video, we are going to discuss systems of linear equations. So systems of linear equations, specifically in two variables. The best way to explain this is with graphing. Here is the URL to a resource that might be helpful to you. If you want more examples, please look here. So here's the example we'll work through together. So a system of linear equations consists of two or more linear equations, each having two or more variables, and we look at them at the same time. So they're considered simultaneously. If we have two equations, like in number 1, hopefully you notice that they're both linear equations, meaning they're both lines. How can these two lines interact with each other? So let me actually scroll down and just get some blank space here, and let's think about lines in general. So one way you can have lines intersect, right? They can interact, and we'll just pretend like that's straight, a little wobbly. We'll pretend like that the lines, I don't know, they intersect somehow. And so if we're trying to find answers that satisfy both equations at the same time, it would make sense that this point of intersection, is where you will have a solution for both lines, right? Some other random point, like let's say there's a point here, that might satisfy that first line, but that's not going to be a solution for the second line because that point's not on that line. So the only point that satisfies both lines is the point of intersection. So this is one way that two lines can interact, is they intersect. And you can see from that there would be one solution. Okay, and again, remember that this is for linear equations with two variables. So two equations with two variables. Everything changes if you have a different number of equations or a different number of variables. So this is kind of just a breakdown, two equations, two variables. Okay, another way two linear equations and two variables could interact is that if you remember, your lines could be parallel. Okay, so this first example was you had intersecting lines and you ended up with one solution. Well, what point on these lines will satisfy both of the lines? If they never intersect, they have no point in common. There's not a point that would be an answer to both of them. So for parallel lines, there are no solutions. So there's no solution because no point satisfies both lines. So no solution here. Another possibility is that you could have a line and your other line, I'm going to use a highlighter, actually lies directly on top of the first line. So in this case, you really have the same line, but maybe it's a multiple, right? Maybe you have, some people might think, well, how in the world could this happen? Maybe you have x plus 2y equals 4, and then the other line is a multiple, like it's 2 times all of that. So it would be 2x plus 4y equals 8. Do you see how I just multiplied every piece by 2? It's really the same line. Okay, it looks like a different equation, but it represents the same exact line. Because again, that second equation, if I divided everything by 2, you would get right back to that original equation. So it's really the same line. So the third option is you could have the same line. Okay, graphically they're exactly the same. And here all of the points are in common, right? If it's the same line and it lies on top of the same line, that means every point is in common. So this would have infinitely many solutions. Right? All the points on the line would satisfy the other line because they're actually the same line. This is really the only 3 things that could happen here. So you could have one solution with they intersect. You could have no solution if the lines are parallel. And what are you looking for in that case? Remember, what you're looking for parallel lines is that the lines have the same slope. So if the lines have the same slope and you see that, then you know that if you're trying to solve a system of equations, two equations, two variables, there's going to be no solution. And then you have the same line. So this is just kind of a general idea. So let's look at what we have here. To solve the system of equations by graphing, you're simply going to graph each line on the same grid and see if they intersect, and if they do, where. That intersecting point is going to be the solution to the system of equations. Now, this is not realistic to do for every problem, right? You don't want to have to graph lines, especially if the lines are crazy. Like one line could be, I'm just going to give you a quick example. Let's say I had 52,861x plus 3,520y is equal to 1, and then negative 4x minus y equals 5. You're going to have a huge grid to do that. And do you really want to graph that? No, right? So that's not a realistic way to do every single problem, but it just kind of gives you an idea of what's happening behind the scenes. The intersecting lines versus the parallel lines versus simultaneous equations, right? The same line. So let's just do it to see how it works. I'm only going to do one example, and then in a future lesson, you will see how to do this in a different way. So there are actually two different ways you can do this. There's the substitution method, and then there's the elimination method, and some people call it the addition method. So we'll see that in a future video. All right, so for this one, I'm going to focus on this top line, and I'm going to do this one in red. So we have 2x plus y is equal to negative 8. So 2x plus y equals negative 8. So I'm going to do that one first. And let's just call this one f. Okay, so I can label it on the grid. Okay. So what I want to do, to me, I like solving these and putting them in y equals mx plus b form and then graphing that way. But this is also set up where you could pretty easily use your intercepts as well. So whichever method you want to use is fine. I'm going to get it in slope-intercept form, so I'm going to get the y by itself, which means I need to subtract, oops, I shouldn't use blue. I'm going to use that for the next equation. Let me use black. So subtract off the 2x, and that would give me y equals negative 2x minus 8. And so there we go, we have slope-intercept form. So I'm going to graph this one. So I've got negative 8, and you can already see that this is a problem because the grid that I provided is not even large enough for this, but we're going to just make it work. So let's say it's like here. So this is negative 7, this is negative 8, so here's negative 8, and the slope is negative 2. If I want to go up 2, because clearly that's going to be on my graph, I don't want to go down because that's not going to be helpful. So the slope is negative 2 over 1. I could go up 2, but then I just have to go left 1, right? So remember, you're using that negative on either direction. So since I'm going up 2, I can go left 1, and that will take care of my negative. Okay, so up 2, left 1. I'm going to keep doing this as much as I can because I'm hoping that the other line will intersect in a nice spot that's easy to see. And see, that's another thing. If you're graphing to try to solve these, if your lines don't intersect at a nice little point, like negative 4 or 0, you're kind of in trouble, right? If it just randomly intersects like here, how do you know where that is? You don't know the exact numbers for that point, and so you can't give an exact answer. So that's another problem with graphing. Okay, now I want to do the second equation. So here's the second equation. So I'm going to, oh, I forgot to label that first one on the graph. So this one is, I should have done it in red, but that's okay. Let me just go over it in red. This one is F. Okay. And now I'm going to do the second equation. I'm going to call it G, and I'm going to do that one in blue. So x minus y is equal to negative 1. Again, I'm going to get the y by itself. So I would get negative y equals negative x minus 1. I want y by itself, so divide by negative 1. I get y equals, that's going to change the sign of the entire side, right, of each term. So we have positive x now and a positive 1. All right, so now I have the y-intercept is a positive 1. I start there. And then my slope, that's the number in front of x. It's a 1. That means 1 over 1. So I'm going to go up 1, right 1, or down 1, left 1. Okay, and then I'm going to connect those. And that will be the line that represents what we called G, right? So the solution to this system of equations is where the two lines intersect. And of course, it's made to where it works out, where it's easy to see, right? The ordered pair would be -3, -2, right? The x direction is -3 and the y direction is -2. So whenever you're looking at the system of equations, your solution, if you have one, is an ordered pair. -3, -2 in this case. If I plugged in this ordered pair to each of the equations, you would see that it works. And so sometimes they give you those. They'll say, hey, tell us if this is a solution to the system of equations. And all you would do, I'll just do one here. I'll illustrate it so that you can see in case you have this on your homework. Is you would plug in the x, which is -3, and the y, which is -2, into your equation. This is the F equation, right? And you check it and see if it works. So 2 times -3 is -6, plus a -2 just means -2. -6 and -2 is in fact -8, so that checks. And then you would check G, right? And so you would say x is -3 minus y is -2 is equal to -1. So that would be -3. The two negatives make a plus, so plus 2 equals -1. -3 plus 2 is -1, so this works as well. Okay, so you can check it by plugging it in, or if they just say, hey, tell me if this ordered pair is a solution to the system of equations, it's really simple to check. You just plug it in both of them and make sure it checks for both.